Hey, good morning, CCTI pre-calc students. Mr. Pashar here once again. I hope everybody is doing well. For this week's assignment number 3, you will see that these are review problems. So typically, as you know, we would have a test at the end. We're not going to have a test, but we're going to still do the review. So this is a mixed review of things such as condensing and expanding log expressions, solving log and exponential equations, and your favorite word problems of growth and decay. So today I decided to do a couple problems with you in terms of expand, condense, and also solving log and exponential equations. As always, if you have any questions as you're going through your assignment, please call or email me. I'll be more than happy to help you through it. So to start off, I have on the board here 2 different problems. The first one is to expand this expression, and the second one is to condense, so they're going in opposite directions. Let's start out with the expansion. We have this expression here, the ln of e times 2x to the 2 power. Okay, so what we want to do is expand this out into its pieces, in other words, break it up into pieces, remembering what our laws tell us. So if we look inside here, notice that we have e times this expression. So the first step should be to understand, well, what do we do with the multiplication? At this point, you should know, of course, that means we're going to add. So we're going to have ln of e plus the ln of 2x quantity squared. Now we have a nice bonus here in the fact that ln of e is a number, right? E to what power would give you e? It's 1. So we got 1 plus. Now this expression here, ln of 2x squared, this is raised up to the power. So we use the power rule to bring this down in front. So this is going to be plus 2 ln of 2x. And then of course this is multiplication here, so we're going to add these. So our final answer is going to be 1 plus 2 times the ln of 2 plus the ln of x. And notice I put the big square bracket around that because this 2 is out in front of this whole expression, which broke down into those 2 pieces. So 1 plus 2 ln of 2x is 1 plus 2 times the ln of 2 plus the ln of x. Okay, so that's a little review. Hopefully you remember that. And now we're going to condense, so that means we want to shrink this down. So we have log of x plus y cubed minus log of x minus y quantity squared. So notice our operation is subtraction. So do you remember where subtraction comes from? It comes from division. So we're going to start off by saying log of x plus y cubed divided by log of x minus y squared. So subtraction is division. And now we're going to go ahead and write this as 1 log, because I think we can see what we're going to do here. This is a power, right? So that's going to come down in front of the log. And that's a power, so that's going to come down in front of the log as well. So what we're going to have here is log of 3 times x plus y over 2 times x minus 1. We could have done an extra step there, but I don't think we needed to. So we go from this to this. Again, the powers just come down in front of the quantity. And that's the condensing. Some people think condensing is harder than expanding, and other people think vice versa. So if you need to, this is a good time to pause the video, go back and take a look, see if you can redo these problems, and I'll be back with you in a moment. Okay, welcome back. So our next step is we're going to look at a couple equations to solve. So the first equation we're going to look at is one that looks like this. It's base 7 log 2x plus 10 equals 2. So we want to solve this thing. This is a logarithmic equation, so remember where your focus should be, on the base, because the base is going to be the base for raising this whole expression up. So what we're going to do is we'll take the base of 7, so you got 7, and we're going to raise it to the log base 7 of 2x plus 10. That equals 7 squared. If you raise the one side by 7, you must raise the other side by 7. Okay? Because of this nifty property with the same bases, we're able to pull this down in front. So we've got 2x plus 10 equals 49. 7 squared, of course, is 49. You go ahead and subtract 10, you get 2x equals 39. And you divide by 2, you get 39 halves. So of course, anytime we have a log equation, we should check our answer to see if it works. So I'll leave the check to you, but it does work out. So this is correct, 39 halves. The check is a fairly easy one. I think you'll see here, this will become 49. 7 squared does give you 49, so game over. Now another type of equation that we have is one where we have to condense along the way in order to do it. So that would be something like this example here. We have log x plus log of x plus 21 is equal to 2. Okay? Now again, we unfortunately don't have a log property that has dual logs in it, so we have to condense this, of course. So we just talked about condensing. This is addition, so we're going to go with multiplication. So this is going to be log of x times x plus 21, and that equals 2. Okay, so we have these two logs are added. That means their guts are being multiplied together. And let's just clean this up and say log of x squared plus 21x equals 2. Now, once we're in this mode right here, we're in good shape because we're going to imitate what we did in the last example, which is use the base. This is a base 10 log, so we're going to raise it up by 10. So what we have is 10 to the log of x squared plus 21x equals 10 squared. Okay, again, we're using the fact of the base. It's invisible because it's a base 10. We assume it to be there. So now this gets to be pulled down front. So you got x squared plus 21x equals 100. So when you look at that type of equation, what should be ringing in your head is that this is a quadratic equation. So we got to get it to look in the proper standard form. So that means we're going to slide the 100 over to the left-hand side. So you got x squared plus 21x minus 100 is 0. That's the format that we have to have. Okay, so we just bring the 100 over. So this is the equation that we need to solve. Well, obviously we're going to get two answers from this, unless it's a double root. But this one will not be a double root. And again, one answer may work, both of them may work, or none of them may work. We have to check it out. So how are we going to go about solving this thing? Well, we have three options, right? You have factoring, complete the square, or your favorite quadratic formula. So how are we going to go and solve this? Well, I would always try to factor first. So let's see if we could factor. So this would be x and x. One has to be a plus and one would have to be a minus. Things that multiply to 100 but give us a positive 21 when we combine them together with adding or subtracting. So what's some of the options? You have 10 and 2. I mean 10 times 10, excuse me. That gives you 100, but when you add or subtract, you're never going to get 21. So I don't think we can use that one. we have 50 times 2, but that's not going to end up giving us a 21. 25 times 4 will give you 100, and in some combination will give you 21. So let's go with that. We need 25 and a 4. The middle term is positive, so that means the 25 has to go with this one here, being that's the bigger of the two factors. And if you check this by FOILing, you'll see that it does work out. So one root is x plus 25 is 0, and the other one is x minus 4 is 0. So when you solve this one, you get x is negative 25. This one's going to be x equals 4. So you have two possible solutions. And now we just have to check in the original. Well, right away, if we plug in the negative 25, that's bad news up here, because that's going to make this negative. That's going to make this negative. We can't have negative inputs for logs. So this guy's going to be thrown out. And the other option left is x equals 4. If we plug that in here and over here, and you go back and check it, you are going to see that it's going to work. So the solution set to this equation is the set of 4. That's your answer. That's the one that works. So we had to condense and we had to factor and solve, and a perfect example of why you need to check your answers, because both of them do not work, only the one does work. So I would urge you to pause here, see if you could go back and solve them, and we'll come back and we'll look at a few other examples. Okay, I hope you're able to manage that. Now let's talk about when we have an ln involved, because ln has a special relationship with e, and that's how we untangle an ln equation. So here's an example. We have the ln of 5 minus 2x equals negative 3. Do you remember what base ln is? If you said e, then you're correct. So what we're going to do is raise both sides by e. So we got e to the ln of 5 minus 2x equals e to the minus 3. Because remember what the property says, e to the ln of some kind of x is that some kind of x. So if we have e to the ln of 5 minus 2x, the 5 minus 2x drops down below. So we have 5 minus 2x equals e to the negative 3, and we just got to solve for x. So we'll subtract 5 over, so you get negative 2x equals e to the minus 3 minus 5, and I'm going to go ahead and divide by negative 2. So x is going to be e to the minus 3 minus 5 over negative 2, and that's going to be your solution for this equation. So that wasn't all too bad. I know I'm going through this a little bit quick, but I'm sure a lot of you are also able to go through these quickly as well. The more of these you do, the more pattern recognition you have. So if we have an ln, we raise up by base e. Okay? Do you remember doing that? I hope so. And then our last example today for now is going to be, well, what happens when we have an exponential equation where we can't change the base? We'll love to change the base because that makes things easy. If we could change the base and both bases are the same, we just set the exponents equal and solve. But 9 times out of 10 in the real world situation, we don't have such nice equations. So we have to be able to do something a little bit different. And that'll be our next example. So here we go. Let's say we have something like 4 to the x plus 2 power equals 5 to the x minus 1 power. So we have 4 to the x plus 2 power equals 5 to the x minus 1 power. This is a problem that you see that we're not going to be able to change the base. We have a 5 and a 4. It's very hard to try to equate a comparable base. So we're going to use the ln. Though your textbook uses the common log, base 10 log, totally fine, no problem with that at all. I was always taught using the ln, so that's just the property that always has stuck with me to this point in my life. So that's what we're going to do here. So the first step, we'll take the ln of both sides. So you got the ln of 4 to the x plus 2 power equals the ln of 5 to the x minus 1 power. Okay? Ln of something to something is that something down in front. So you're going to have x plus 2 times the ln of 4 equals x minus 1 times the ln of 5. Unfortunately, the ln's don't go away here because they're not an ln and an e. If you had ln e to the x, it's just x. But we don't have that. We have a number other than e. So what we'll do at this stage is we'll distribute, right? So this is going to be x ln 4 plus 2 ln 4 equals x ln 5 minus ln 5. So all it is basic algebra. Distribute through like you normally would. And again, our goal is to solve for x. So that means you've got to get x on one side. Usually I try to get it on the left-hand side, but it doesn't always have to be that way. But I'll do that here. So that means we want to get the x's on the left and the pure ln constants over on the right. So I have x ln 4. If I bring this over, that becomes minus x ln 5. Now I'm going to shift this over to the other side. Minus 2 ln 4 minus the remaining ln 5. So it's just a little bit of trickery here. That's all, is moving things around. These both contain an x, so we're going to factor out the x. So you have x times the quantity, ln 4 minus ln 5 equals negative 2 ln 4 minus ln 5. So again, they both have an x in common. You can't subtract these because they don't have the same ln number. This is the ln 4, that's ln 5. It's very tempting to be able to want to subtract them, but you can't. So over here now, I'm going to divide both sides by ln 4 minus ln 5. Remember, those are just numbers, they're not variables, so we're able to do so. So these cancel out. You're left with x equals negative 2 ln 4 minus ln 5 over ln 4 minus ln 5. And that would be your final answer. And as tempting this may be, right, you cannot, as I say, illegal, you can't chop anything here. It'd be illegal chopping, right? Remember, I always would, from September to this point, I always use that term illegal chopping. This would be illegal chopping to cut the ln 5s out, cut the ln 4s out, and just say you have a negative 2 left. Illegal. That's illegal chopping. And those who do it, you know who you are out there in my pre-calc classes, so don't do it. This would be your final answer right here. So the solution says negative 2 ln 4 minus ln 5 over ln 4 minus ln 5. That's it. I hope these problems helped you a little bit as you do your third assignment, being a review. If I get enough interest, I'd be inclined to do another video on word problems if you would wish. That's no problem. I'd certainly be able to do it. But hopefully this helps you to get started on your assignment that's due on Monday next week. So until then, I hope everybody stays healthy, safe, well, and I will see you when I see you.